Hi everybody, welcome back. I hope you watched the flowcharting part of this video. So important to understand that technology, how to use it, how to design your conditions, how to design your algorithms. And with that knowledge, we can now go into the coding of it. Now, in this video, we're going to talk about if statements, if else statements, else. We're going to talk about how to make decisions, how to take those flowchart designs and convert them into something that can actually be implemented in C and C++. And most of what we're going to do today is also available on C as well as C++. So let's get started with it. So let's say you wrote a little program, and actually let's kind of do what the flowchart did. I'm going to ask the user to enter in A and B, and then we're going to calculate C. Now to do that, we need CMath. And I'm going to ask the user to enter that data in. Now there's hello world. I'm going to say count, and I'm following the flowchart that I did in the previous section. Please enter the value for side A. And then from there, I'm then going to do a CN to A. Now we haven't actually created A yet, so let's go ahead and create some floats. If you remember in the flowcharting, we needed a variable called the hypotenuse. We needed a variable called A. We needed a variable called B. And we needed a variable called C. Now the reason I'm using floats is because they're smaller. You can use doubles if you want. I'm all about conservation, using as little memory as necessary. Now, we do need our clear kin. If you remember in my other videos, I created a function called clear kin, and that simply did a kin.clear, and then a kin.ignore. And to use int max, we have to pound include C limits. Now, even though this doesn't look like a lot of code, to me that's a lot of code before doing a build. So I'm going to do a build and make sure I don't have any errors. We do have some warnings, that's fine. Okay, so then we have to do the clear kin. Now remember, the rules for doing the clear kin or the clear sin is that it's only done after numeric sins, after numeric kins. So, okay. So now we have to ask the question, is A negative or is it equal to 0? So I'm going to say if A is equal to 0, and this is the format of the if statement. You have an if, and then in parentheses you have the condition that you want to test. And the output of that condition is either true or false. And remember, true is yes, false is no. Notice I also have the open and close braces. I don't really need those. Well, I do, but they're not syntactically required. So if A is equal to 0, I'm going to say cout, A cannot be 0. Please try again. Now, I also want to check if it's less than 0. So I'm going to say if A is less than 0, I'm going to say sout or cout. All right, this will work. So the if statement, the first if statement is asking if it's equal to 0. It's asking if it's less than 0. Let's run this. Let's see if this works. And we're gonna. And I always like to test my code to make it break. All right, please enter a value for side A. Let's put 10 first. Okay, it didn't really do anything. Now this is another argument for why it's a good idea to have some sort of a program ending, because we don't know if the program died or if it ended correctly. So we're kind of up in the, we're not sure. So let's build it again. Let's run it. Okay, let's put in the number 10. Okay, good. It ended, it went to completion, so the program ended. So let's go ahead and now run it, and this time let's put in -10. Oh, A cannot be less than 0. Please try again. Awesome. Let's put in 0. I'm testing all conditions. A cannot be 0. Please try again. Now this is a little bit confusing because it says please try again, but I have to rerun the whole program. Well, okay. Let's see how we can make that better later on. So I'm going to copy all of this because B has the exact same problem, is that it can't be 0, it can't be less than 0. So I'm going to put B there. And I'm just going to change my messages. And I'm going to change my conditions. And let's build and run it. And let's see how this works. So please enter the value for side A. I'm going to say -10. Now, here's the problem. Is that the program, well, first of all, we have the program ending in the wrong spot. So let me stop this. And let me move that. Oh, nope. It's already down there. I just copied it. All right. So let's run it again. Okay. Now I say -10. It says A cannot be less than 0. Please try again. But now it's asking me to enter in B. It's not actually asking me to try A again. So how can we get back up, like the flowchart showed us, how can we get back up to where we're entering A again? Well, I'm going to click the stop here. Well, the way that you can do that is with a thing called a Goto. Now, oh my God, he said it. We're going to come and find where he lives. We're going to eliminate him from the planet. Well, Gotos are really great ways of beginning to teach transfer of control to different parts of a program. And they're not very well accepted in the industry any longer, but it's the way that you must do them in assembler language. There is no such thing as a loop, like a while loop or a do while loop. You do have to, and we haven't done that yet in this class, but you do have to be able to move around. So what I want to do is, I'm going to create a label called enter A. Now notice how that label is. It's the word enter and then the capital letter A. It uses the same rules as variables, but it has a colon at the end. And that makes it a label. So after I count, cannot be 0, please try again, I can say go to enter A. And I can do the same thing down here. Now, some of you that have already messed around with if statements knows that we have a problem here. Okay? And let's demonstrate it first. Notice how I indented. And let's go ahead and run this. Did it build correctly? Yep. Let's go ahead and run it. Okay, so I'm going to enter -10. Okay, it seemed to work, but it didn't really give me an error message. Now, the reason why it didn't give me an error message is because let's look at this code. It asked if it was equal to 0. Well, it wasn't equal to 0. It was less than 0, so it didn't print out it cannot be 0. Why did it go to enter text? Because this line is not part of the if statement any longer. Even though it's indented, which is how you do it in Python, it's not actually part of the if statement any longer. So I'm going to stop this. To make it part of the true portion of the if statement, I'm going to put open and close braces there. That means that both of these lines of code are part of the true result of that if statement. So the first part of the if statement is the true part. The second part, which we'll talk about in a little while, is the false part, where the condition was not true. And so if you have multiple lines of code in your if statement for a specific condition result, you have to put in into curly brackets. Now, I do that whether I have multiple lines or even one line of code. And it's kind of like using the turn signal in your car. If you use it all the time, whether or not you need it or not, you won't forget to do it. It's the same thing here. It's the same rule of thumb. Using open and close braces on one line of code is going to be no different in the size of your code, the speed of your code, than if you don't use it. So it's just a way to better organize your code. So what I did was I just put in those curly braces. I'm going to run this again, and let's see how it works now. So I'm going to say -10. Okay, great. A cannot be less than 0. Please try again. That's awesome. So what happened was is that I typed in -10. -10 is not equal to A, or A, which is -10, is not equal to 0, so it skipped all this. So if A, which was -10, is less than 0, which it is, it did this line of code, then that line of code, took us back up to here, and printed the count. It allowed me to do it again. So that's our first loop. Now this is, again, there's some of you that know programming, maybe on this video, that may say, oh my God, he's using Goto. We're just using it to introduce loops to you, because that's the next thing that we're going to go through in this course is loops. So that is an old man's way or an old woman's way of doing a loop. But it works, doesn't it? So let's go ahead and now type 0. A cannot be 0. Let's type 20. Great. So it was not equal to 0. 20 is not equal to 0. It's not less than 10. So it then continued on down here. So that is a way of doing it, and let's go ahead and do that for B as well. Now I'm going to just copy and paste, and we're doing everything that the flowchart said we should do. So now the label has to have a new label name, so this is for B. So I change it to enter B, and I'm just changing all the messages and the variable names. Let's make sure we change that to B. All right, great. Let's see how this works. Okay, I like to test everything, so I'm going to do 0. Looks good. -10. Looks good. I'm going to type 10. Awesome. Now for B. 0. B cannot be 0. -10. Looks great. 10. And the program ends. That is awesome. So our program is working. Our little Goto loops are working, which again, I'm sure I'm going to get bad comments, but it's how I teach it. So now we have to do the calculation. Now I'm looking at the flowchart over here on my other screen, and after both of those values have been entered incorrectly, now the question is, how do we actually calculate it? Well, we calculate it by saying hypotenuse is equal to the power of A raised to the 2 plus the power of B raised to the 2, and then we have to do the square root, and that's SQRT. And that's hypotenuse. Now I'm going to save and build that to make sure that it's cool. All right, looks good. Now we want to print that to the screen because that was the next thing that the flowchart said. So we're going to say count the length of the hypotenuse. Is that how you spell it? I don't know. Is. I'm going to say height. Move my mouse. All right, let's save and build that. Let's run it. So I know those work. I know those validations work, so I'm not going to test them again. And the length of the hypotenuse is 14.1421. Now the flowchart now said, do you want to do it again? So we have to have another if statement. I'm going to say count, would you like to do this again? Now you might want to tell them type a Y or an N. And I'm going to say can. Now we need a variable for the answer, and we have that in the flowchart, but we forgot to initialize it up here. So I'm going to say char answer. And instead of a kin, we're going to do a kin.get. Now we're not going to validate whether they typed a Y or an N or if they typed a Z or an F. Let's assume they typed a Y or an N. So I'm going to say if answer is equal to. Now this is the first time we've actually no, it's not. We did that with equal to 0. So if answer is equal to Y, I'm going to go to, and I believe it was enter A. Else I've decided that I'm going to put my program ending there. I'm just going to assume they type an N. All right, let's see how this works. All right, let's type 10. 10. There's my hypotenuse. I'm going to say yes. It asked me for A again. 10, 20. There's my hypotenuse. I'm going to type no. I'm also going to type Z, because even Z will let me get out. So I could do something like this, yes, or anything else. I could do something like that to make it useful. So that's our first conditions. That's what programs are all about. Now, there's something new here that we hadn't seen, and that's the else statement. So if you have an if statement that's actually a question, the go to enter A will occur if the answer is equal to Y. That's the true condition. Else, if it's false, if answer is not equal to Y, it's going to do this, and then it's going to fall through and go to the return 0, which is the end of your program. So that's the else. So this is the true portion of the if. This is the false portion of the if. And notice I have them in open braces because it just is easier for me if I want to add another line. It's just going to work. Okay, the open and close brace is already there. I've gotten myself, early in my career, I got myself into a lot of trouble because I wasn't using open and close braces. This just fixed that problem. Again, it's just like using your turn signal in your car. So that's the if-else. Now, we didn't use an else up here. Well, if it's not equal to 0, we might want to ask another question. Else, if is less than 0. So that's another type of condition, is the else if. It's like an or. If it's equal to 0 or if it's equal to -0, I want to do something. I want to display an error message. So there's also the else if, and we can do that in both, for A and for B. Now, we've done a bunch of stuff here, so let's save and build it and make sure it still works. Okay, so let's put a 0. Cannot be 0. -10. Cannot be less than 0. Works great. Let's try B. 0. -10. Works great. So else if is a way to ask another question if the first if has a negative outcome. Now, for program completeness, and some of you may think I'm crazy for doing this, but some companies actually required it. For program completeness, there's still a condition. If it's not equal to 0 and it's not less than 0, it must be greater than 0, which means it's positive. So I could put an ending else there, count good value received for A. That is what I call a mathematically complete if statement, because every if has an else. And it used to be, and I don't know how it is now, but it used to be where you had to mathematically prove that all of the logic in your program is correct, mathematically correct. So like for every if, you'd have a value of 1. An else if would have a value of 0. So you'd add 1 plus 0 is 0. And then the else has a value of -1. So 1 plus 0 plus -1 is 0. So this part of my code is mathematically complete. And it's not a bad practice to get into. So those are complete values. So let's see how that, or if statements. So let's see how that works. Okay, I'm going to check -10. I'm going to check 0. I'm going to check 10. All right, so you've told the user that 10 was accepted. I'm going to say no, 10, 10. Let's put, oh, I put in a 10. Good value received for B, and there is my hypotenuse, and I'm going to say no. So those are if statements. So, and if statements are used all over computer science. Now, there's another way that you could do this, and that's what I call a complex if statement. So what I'm going to do is I'm going to use my mouse, I'm going to use my cursor keys, and I'm going to select all those lines by pressing Shift down, and I'm going to press Command/. I'm going to comment all that code out, And I'm going to show you another way that you could do this using what I call a complex if statement. I'm going to say if a is equal to 0, or this is actually the standard way of doing it, or a is less than 0. So I could put two ifs together in a single if. I could say count a must be greater than 0. And then I could say go to enter a. Else, they entered a good valid value, good value received for a. So this is kind of a shorthand way of doing an if else by using this or. Now you can in the newest versions of C++, you can say or, the word or. Both of them are the same. Let's actually make sure that I actually think that it's lowercase or, I believe. I believe it's lowercase or. There we go. The problem with this is that you don't know if what you typed in was 0 or negative 0. Let's say you accidentally typed a negative 10. You meant 10, but you typed a minus 10. Well, why is it telling me it must be greater than 0? It's not giving me the detail that I need. So that's where these if-else ifs really shine, is that you can specifically say what the problem is. And the code is probably well, not probably, I know it's very, very close at the machine level. These two groups of code are very, very close. The difference is that you have different error messages that are displayed. And those error messages can help guide the user. The code's going to be a little bit larger, a little, not slower, but a little bit larger in the machine code that's generated, but it's going to be much more informational to the end user, to the person who's using your program. So I can build this and run it, and you can see what I mean. I don't know if I typed a 0 or a negative number. I mean, I can see it there, but in a more complicated user interface, it might be kind of confusing. Must be greater than 0. Okay. Well, in this case, it's not too bad of an idea, but in my opinion, from a user interface, quote-unquote experts, arguably expert point of view, I think the if-else if is a little bit better because it tells you what the actual problem is. It cannot be 0. It cannot be less than 0. Okay? So it's a little bit, in my opinion, it's a little bit more complete. Now, there's something else that you could do. That was the or. And actually, let's go back to that. You could actually do the same thing with what we call an and. So another way I could write this code is I could have them enter in A and B right after each other. And then instead of doing this, I could say if A is less than or equal to 0. That's another condition, less than or equal to 0. Or let's say A is greater than 0 and B is greater than 0. So now I'm talking about the positive case. I could then calculate the hypotenuse. You're going to really like this. It's going to get really small. I'm going to put that up here. Get the square root, else I'm going to say either A or B are less than or equal to 0. So kind of nice, right? You've taken that with the and you've had them enter them both in. Now the problem with this, in my opinion, is that if they enter a negative number for A, why are you going to let them enter a number for B and then give them an error message anyway? Why make them enter a negative number or enter B when A is already incorrect? So again, this is something you could do in your flowchart to get your logic together. Let's actually see how this works. So I've already entered B, so I'm going to comment out all of this. I've already calculated the hypotenuse, so I'm going to comment out that. Look at how small my code has gotten. And let's run it. So I'm going to say negative 10. But the problem here is, as I said earlier, I'm allowing them to enter B when A is already incorrect. Let's put a 10 there. And so I'm going to press enter. And now it's telling me that either A or B are less than or equal to 0. Would you like to do this again? Yeah, okay. I'll do it again. Let's put in a 10 for A and this time a negative 10 for B. So the logic has changed. It's not letting me go back up and type in the invalid value. I mean, we could probably... Actually, no, we really couldn't, because this is very limiting. The code is much smaller, but from the user's point of view, it's not as usable. I'm tired of using this because it's making me do things that I don't want it to do. So the AND is a logical operator that lets you make sure that both of these must be true for this to be executed. If either one of these are false, this will be executed. So that's what the AND is. If you remember the OR, either one of them, remember when we had OR here, either one of them could be true and this will happen. If neither one of them are true, then that'll happen. So that's really the difference between AND and OR. And you can see that as I'm trying these things out, or as I'm coding it, I'm saving and then building and then trying them out right away to see what's better. So as I said earlier, I really like this method better because I'm really giving the user a lot of information. The code is longer, but you're not writing a program to make it easy on you as the programmer. You're writing it to make it sellable to the user. So those are ifs. Now there's also another thing called a nested if, which can get really complicated. Let's go ahead and I'm going to leave this the way it is right there. And what I'm going to do is I'm going to create a nested if. So I'm going to say if is equal to 0, or if is greater than, and I'm going to say greater than or equal to 0. I could then ask if B is greater than or equal to 0. So this is what we call a nested if. And a nested if means that I've got an if inside of an if. Now notice I don't have an open brace at the end. I really should. Okay? And I have to close all my braces. I also like to put comments at the end of each brace as to who they belong to. Now it may seem kind of weird to do that with such small ifs, but as your ifs get longer and longer, that's going to be very, very useful. So if A is greater than or equal to 0, if B is greater than or equal to 0, then I'm going to do the hypotenuse calculation. So a nested if like this is like an AND. And each if needs to be completed with an else. So, well, let's see. Yeah, this can get kind of confusing. So, so let me see. So, if true, so we have to put a closed brace there. There we go. So, if A is greater than 0, and if B is greater than or equal to 0, calculate the hypotenuse. Otherwise, B was not greater than or equal to 0, so we have to say B cannot be 0, and then we're going to have to say enter B. So that's the else for this. Else, we have to now say A cannot be So we'll make A, and we'll go back to A. So that's another way we could do this. Now, this is a little bit freaky. This is now becoming what we call spaghetti code, is I'm going to labels at different parts of the program. Ugh. So you have to be really, really careful with Gotos, and you really shouldn't use them at all, but it's kind of a good way to, as I said earlier, to describe these small little loops. But this is a nested if. And as you're doing this, you need to actually take a look. And again, the flowchart would actually show this as a nested if, but the flowchart wasn't written in such a way that it's a nested if. The flowchart is actually showing it more of a non-nested if, the very, very first one that we had. But you can do all kinds of things with these ifs. The important thing is to make sure that you've put them in the right brackets. Make sure that you're not outside of the brackets and it's not going to do things that you don't want it to do. So there's got to be a lot of changes to this. We have to put enter B in here. So I'm going to go ahead and make those changes up here. Oh, so we already did that. So I have to create enter B here. Enter A is there. So that's already there. So that's cool. Let's clean up some of this code. And now we're going to get rid of this enter B there. We no longer need the hypotenuse calculated there. All right. So you might look at this and say, I like this a lot better. Okay, that's fine. A lot of it is style, but you also then have to look at what the user is going to see. So let's try it again. I'm going to say negative 10. See, this is another example of doing it this way. You're forcing the user to type in B when they already have an error in A. A cannot be 0, try again. Okay, that's good, but B wasn't negative or 0. So I'm going to make them type in B again because I had a problem with A. Same thing here. B was equal to negative 10. I'm going to make them type in A again because I made a mistake with B. And now look. Okay, so this was pretty good. So this was a little bit better. It went back up and had them enter B because B was down here. So when we re-entered A, it then came down to enter B again. So you can see how this is getting kind of confusing. And by doing nested ifs, sometimes nested ifs are great, sometimes not so great. Again, these are tools that you can decide how you want to implement them. But what we've gone through is we've gone through equals, double equal sign down here, like if the answer is equal to y. We've said greater than or equal to. We've said greater than. We've said less than, equal to. These are all different. There's a not equal to, so we could actually change this. If it's not equal to y, we could switch them. So not equal to, the bang or the exclamation mark equal, that's a not equal to y. We just switched the true and the false values. And that's called negative logic. I love negative logic. Most people don't. So with the not, you can use the opposite of what the result is. And that's if statements in C and C++. We went through complex if statements, simple if statements, if-else statements. We did an awful lot. A little bit long of a video, but I hope to see you at the next one.